This video is for standard algorithm of subtraction. This is the standard algorithm is the method that most of us learned growing up when we were learning how to subtract. So it's basically rules to follow, procedures to follow, kind of like addition. You're going to start in the ones place and you're going to subtract going down. So I made these in like a sequence, like this is the easiest problem, this one's a little bit harder, and this one's the hardest concept to get. So we're going to start with this one. For standard algorithm, you're going to start in the ones place. 4 minus 2, that gives us 2. 9 minus 8, that gives us 1. And 2 minus 1, that gives us 1. So why does this work? It's relying on place value. So with this, we're showing that, and I know I used a place value chart in the standard algorithm of addition, but it really is the best way for them to understand what they're doing. Okay, so I have 2 hundreds, and I have 9 tens, and I have 4 ones. I have seen the little place value discs where there are 2 different colors, they're red and they're yellow, and you assign positives to be one color and negatives to be the other color. So when you're subtracting them, you flip it to where you know that the negative color, I think it's the yellow color, is negative. When you flip it, you understand that that is now a negative number or that is taken away. I'm just going to do it like this though. So 294, so I'm subtracting 182. So 100, I'm going to take away 80. 1, 2, 3, 4, 5, 6, 7, 8. And I know that's 80 because it's in the tens place. And 2 ones. 1, 2. So I'm going to write what I have left. I have 100, 110, and 2 ones. 112. So the reason this works, it's relying on place value. 4 minus 2, I had 4 ones and I subtracted 2 ones. 9 minus 8, I had 9 tens, I subtracted 8 tens. 2 minus 1, I had 2 hundreds, I subtracted 100. So relying heavily on place value, this is the ones, this is tens, this is the hundreds, and you subtract going straight down. So now for the little bit harder question. I guess I could have left that, huh? Okay, so this one's a little bit harder because you're going to have to borrow. That's at least what they called it when I was learning. So, 0, 9 cannot be taken away from 0. So, we have to go next door and borrow. My teacher would always say we got to go next door and borrow some sugar or something like that. So, you're going to cross it out and you're going to subtract 1 from this and give it an 8. So where does that 1 go? We're going to add it to the 0 and give it a 10. So when I was coming up, I didn't understand that the reason this works. Again, I'm going to go to the place value chart. I guess I should have left it up. I didn't understand that the reason this works is because you're taking 110 away, and 110 is the same as 10 ones. So when you move this over, it becomes 10 ones. It seems like a simple concept now. I don't understand why I didn't get it. But I just thought that because we took 1 away from the 9, we just put the 1 in front of the 0. So when we got to problems like this, I was heavily confused. So we took 1 away from the tens place and we gave it to the ones and it created 10. So we actually added the 10 to the 0, and 10 plus 0 is 10. We did not just add the 1 in front of the 0 to make it a 10. So 10 minus 9, that gave me 1. 8 minus 8, that gave me 0. 2 minus 0 is 2. Okay, so I'm going to show this on the place value chart a little bit better than I just did. A little more context. So I have 2 hundreds. I have 9 tens. 5. Did I just do 10? I just did 10. 9. And then I have no ones. Okay. So I have 290, and I have to have 89 taken away, or I have to give 89 away. So when I do that, I'm going to start with the ones, but I don't have any. So I always like to relate it back to money. You could say you have a $10 bill, you owe me $9. How are you going to do that? Well, you need to break down that 10, right? So I'm going to take this and I'm going to move it over here, and it's going to make 10 ones. So now this isn't here anymore. That's where we got the 8. And now we have 10 right here. That's where we got this 10. If someone would have shown it to me this way, I feel like I would not have had so much trouble with subtraction in school. Because for whatever reason, I thought we were taking 1 from here and just adding it to the front of the 0. So when I got to other problems where this wasn't a 0, it was maybe a 2, I just thought we were adding a 1 in front of the 2. Which I guess that's kind of what you're doing, but I didn't understand this concept. So now I can actually take away 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now this can visually show me that I have 1 left, just like we got up here. So now I have 8 left right here, and I have to take 8 away. So obviously we're going to have 1, 2, 3, 4, 5, 6, 7, 8 taken away, and we're going to be left with nothing. Now we have 200. I don't have to take any away from the hundredth place. There's not a number there, so I'm going to leave it. And this gives me 201, just like we got up here. So that's why this works. You're not just going next door and borrowing some sugar. You are actually taking 110 away, kind of like you could take a $10 bill, and you can make change. You can make it into 10 ones. You're taking the 10 from here and adding 10 ones to the ones place. Okay, and I'm probably going to use this again, so I'm just going to erase this. Okay, so now for our harder problem. These killed me when I was learning subtraction because I thought you were adding a 1 to the front, so I didn't understand how to do it if there were 2 zeros here. So I have 0 minus 2. Well, we're not going to do that because the students may not have learned negative numbers yet, and it's not the standard algorithm to do that. So I'm going to go next door to borrow 1. Well, look at that. This is a 0 as well, so we can't borrow from them. So we're going to have to go to the next door neighbors. We're going to cross it out and make it a 1. So what we just did, which I never understood when I was learning, we just took an entire 100 away. We didn't take 1 away. We took an entire 100 away. And then my teacher taught me that since we took 1 away from here, we could bump. This is a 9, this is a 10. She taught me the bounce. She called it the bounce method. So it's like bump. So like if we had like 200,000 minus 19999, she would say you take away this 1 and then you're like boing, 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 boing. This last one's 10 and all of these are 9s. If you bounce off the 0, it's a 9. If you land on the 0, it's a 10. That's what I was taught. Which is fine. I learned how to do it. I didn't quite understand what I was doing, but I did it. So the better way to explain this, not the bounce, we just took an entire 100 away from here. So we have 2 hundreds, and no 10s, no 1s. I need to take 2 1s away from this, but I can't. So I'm going to go next door and borrow some 10s. I don't have any 10s, so I'm going to go next door and borrow 100. So I'm going to take an entire 100. How many 10s is a 100? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 100 is the same as 10 10s. So now technically this 0, because we haven't moved it yet, this 0 just became a 10 because we haven't moved these yet. Okay, so now the reason this 0 becomes a 9, we still don't have any 1s to take 2 away from. So, just like we did before, we're going to take one of these and move it next door. And that gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ones. So this is why you take 1 away from the hundreds place, and then you bump, this is a 9 and this is a 10. It's because you're taking 100 away, it turns into 10 tens. You still don't have any ones, so you take 1 10 and convert it to 10 ones. So you're left with 9 tens. 9 tens. It's a little confusing, sorry. So now that we have the 10 ones, that's why this is a 10 and this is a 9. That's why we can take one away and bump. That's a 9. We landed on that. It's a 10. 10 minus 2. 1, 2. We're left with 8. 9 minus 7. Now we can do this. This one is moved over here, so I can't count that one. 1, 2, 3, 4, 5, 6, 7. And I'm left with 2. And then I have to take 100 away right here. So 1 minus 1 gives me 0. So my full answer is 28. And this is why. This is why you're crossing off 1. You're not borrowing 1. You're not adding a 1 to the front of the 0. You're actually taking 100 away from the hundreds place. You're taking 100 away. And you're converting it to 10 tens, and then you're taking 1 of those tens away, giving us 9 tens, and you're making it into 10 ones. So the same goes if you have that 200,000 minus 199,999. You cross out this 1, you're taking away 100,000, not 1. And then you're going to boing, 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 boing. You land on this one, it's a 10. These are all 9s. That's why. You're taking away 100,000 because 10,000s is 100,000. Am I going too far into this? This is why you can just bounce. And the last one is a 10. Because you're continually moving one over so that you can subtract. And so that you have enough to subtract. So this is standard algorithm. It may not be the easiest to do in your head, but this is what most of us learn growing up. It is heavily based with place value, as most strategies are. This one, you try to borrow, you can bounce the zeros, you can use 9s. I think someone said there's none on the floor, gotta go next door. There's cute little sayings like that, which are great to help the students remember, but you need to remind them why this is working. You're not just going next door, taking 1, and then this just randomly becomes a 9. You need to make them realize that you're taking away 100, this is becoming 10 tens, and then you're taking 1 10 and giving it here, which is 10 ones. You need to make that connection for them because, like I said, when they get in those higher grades, they're just going to remember what they did, and it's not going to fully click with them.